8.2 combinations. A combination is the number of ways to choose some subset of R items out of N items without putting them in order. Or in other words, order doesn't matter. Order doesn't matter. It's a group from a larger group, and order doesn't matter. There's a formula for it, and it looks an awful lot like the permutation formula that we had before. N factorial over N minus R factorial R factorial. So that's the formula. If you ever found yourself without a calculator, that's how you could calculate it. But honestly, I'm probably just going to use the combinations function on a calculator. So, there's the formula. If you had to in a pinch, use it. Otherwise, just use your calculator buttons. So remember also, it's a group from a larger group. Very similar to permutations. The difference is a permutation order mattered, like ranking the ways that runners could finish first, second, and third in a race. And then combinations order does not matter. It'd be like, how many ways can I pick 3 of you to be on a committee? Who cares who got picked first? It doesn't matter who's first, second, third, whatever. I'm picking a group from a group. Order doesn't matter. Example 1 talks about a committee. Consider a group of 8 people. How many ways can you form a committee of 3 people? Okay, well, I see 8 people. And we're going to do a combination of 3. Or, of course, you can write C8, 3. Or on your calculator, you're going to write 8 in CR3. However you want to write it. It's 3 people out of 8 people, and order doesn't matter. So on your calculator, you can find your NCR function in the same place as your NPR function. 8C3 is 56. If you wanted to use the formula, it would look like this. It'd be 8 factorial over N minus R in the formula. 8 minus 3 is 5. And then 3. Okay, that would be your formula. How about a committee of 5 people out of the 8? And that's just going to be 8C5. 8C5. Also 56. Which brings up an interesting point. There were 56 ways of choosing the 3 people to be on a committee. Isn't that the same thing as me saying, well, let me pick 5 people that are not on a committee? Okay, if you've got 8 people sitting in a room and I want to pick 3 of them to do something, it'd be the exact same thing as picking 5 people to not do that same thing. And so that's why these 2 answers are the same. 8C3 and 8C5 are really doing the same thing. Number 2, Jack Jackson is one of 30 lawyers at a firm. 3 lawyers from the firm are to be selected to work on a special project. And how many ways can the 3 lawyers be selected? So the first thing you want to notice is I'm taking a group out of a group. See how you want 3 out of the 30? It's a group out of a group. So you need to ask yourself the question, does order matter or not? Okay. Does the order that I pick these lawyers matter at all? No, it doesn't. That makes it a combination. 30C3. $4,060. Part B, in how many ways can the 3 lawyers be selected if Jack is one of them? Okay, now we get a little bit more complicated. Sometimes it's not straightforward and you really have to think about it, okay? So think really hard. If they said Jack is one of them, there's an implication there. The implication being Jack and 2 others. Some of these problems will be worded in a kind of confusing way. I think it's a really good idea to rewrite it using the words and or a lot of the times. Okay, if you can simplify the problem into exactly what's happening, there's Jack and there's two others, I think a lot of the times that can make this problem doable. All right, so think about it this way. And means time, so I just changed this into a fundamental counting principle problem. All right, that's a blanks problem. This and this, so you're going to multiply two things together. So think about it this way. How many ways are there for me to pick Jack? Just one. There's only one Jack. Okay, there's only one Jack Jackson, so we're going to pick that one guy. And now I have to pick 29 others. So think about how I'm going to be able to pick, did I say 29? Two others. I need to pick two others, right? Is it a group from a larger group? Yes, it is. Does the order in which I pick those two matter? No, it doesn't. So that's going to be a C. That's going to be a 29C2, right? 29 because you took Jack out of the equation, right? There's no Jack. I'm not looking at Jack. I'm looking at the 29 others. I'm picking two others out of the 29 others. There we go. It's going to be 1 times 29C2. That's going to be 1 times 406. That's 406. And how many ways can a group of at most 3 lawyers be selected? So again, those of you who are going to be good at this are going to be good at simplifying what that means into exact terms, okay? Exactly what does at most 3 mean? Anybody? No more than 3. Okay, yes, but I want to be precise. That's pretty much saying the same thing. Let me reword. I want to reword at most 3 into language using the words and or. Okay? So can somebody give me a phrase using the word or? What's at most 3 mean? There you go. Okay, there you go. There's going to be 3 lawyers or 2 lawyers or 1 lawyer. Technically, you could say or 0 lawyers in a group, so I think you could probably argue that. So think about it this way. That's good. That's what I want. 3 lawyers or 2 lawyers or 1 lawyer or 0 lawyers. I think you could make the case that it's not, don't count the 0, but people who are good at this are good at seeing that that's what they're talking about. Okay? And what you're going to have to know at some point, remember how we know that and means times? Or means add. Okay, so I like breaking my problem into an and an or, and when I see this or, I've got this plus this plus this plus this. Okay, that's what I'm looking at. How many ways can a group of at most 3 lawyers? Well, let's just break it down. Let's just look at 3. Okay, how many ways were there for me to select 3 lawyers? Well, we already did that, right? It was 30C3. Okay. What about 2 lawyers? Well, that would be 30C2. Or 1 lawyer would be 30C1, and 0 lawyers would be 30C0. Okay. Anybody know how many ways are there to choose 0 lawyers out of 30? Not 0. 1. There's only 1 way to do it. I'm just not going to pick anybody. That's the 1 way, okay? So we can do 30 choose 3. 30 choose 3, we already did that, was 4,060. Plus 30 choose 2. I don't think we've done that yet. 30 choose 2. It's 435. 30, choose 1. You're going to be able to do that one in your head at some point, but maybe not right now. 30, choose 1 is 30. Basically, that means you're only picking one person. So there are 30 ways to only pick one person. That should make sense. And then 30, choose 0 is 1. There's only one way to do that. So add those numbers up. 4,060 plus 435 plus 30 plus 1 is 4,526. Now, again, I say that, and some people might argue, yeah, but a group of 0 lawyers is kind of silly. So you might also think about it as 4,525 non-empty groups. Okay, if you ignored that one.